So today we are going to be reviewing for your test tomorrow that goes over vectors, friction, and forces on an inclined plane, also known as a ramp. Okay, so we're going to start with this question. We're going to break it down into all of its little bitty pieces, and then we'll do a couple more example problems as well. Okay, so what we have here, it says a 215 Newton box is placed on a ramp that is elevated 35.0 degrees above the horizontal. So what we're going to do first is we're going to draw the original free body diagram for this. So we start out by drawing a ramp, and the angle theta is equal to 35.0 degrees. All right, my ramp's not long enough because I got to put, a little box on there, right? Okay, and anything that's on the earth has something that pulls it down, and that's called gravity. So going straight down, we have Fg, which everyone knows is equal to what? Well, not 9.8, it's mg, there we go, which is equal to the mass times 9.8, but in this case it says that it is 215 newtons. Okay, now, this is not falling directly through the ramp, correct? No, it's not. Good. So that means that there is some sort of force perpendicular to the ramp called the Fn, or normal force. Let's see if I can move this whole thing down real quick. There we go. Get it out of there. Okay. So we have this normal force. Remember, normal means 90 degrees. So it's 90 degrees to the surface. Okay, this is the original free body diagram for the problem. Okay, the problem says it wants the parallel component of the weight, the perpendicular component of the weight. Then it wants us to figure out what the net force on the box is with no friction, and then what's the acceleration of the box is if there is friction, and it has a coefficient of 0.240. So we're going to make the simplified version that we took notes on Friday, and that we've been using all week, and we did the lab on, and all that fun stuff, right? Okay, so we're going to redraw this where we break up Fg into its components. So that means that we still have our box here. This is still 35 degrees, 0.0. But we now have this right here, which we call Fg parallel. And that's the symbol for parallel. I know it looks like an 11, but it's parallel. And then we have Fg perpendicular. Okay? And then we still have the normal force point straight out of the ramp at that 90-degree angle. This is still Fn. Okay? So at first, we don't have any friction, so we're not going to put FF on this free body diagram. We're going to draw another free body diagram wherever we get to friction. Okay? So that's what we have so far. So the first question is, what is the parallel component of the weight? So these were our givens up here. The unknown is the parallel. So that'd be Fg parallel. And we've already talked about this, and we wrote down these formulas yesterday. So what is the formula for Fg parallel?
Mg cosine sine theta.
Mg sine theta. Okay, so we can go ahead and solve for Fg parallel. So Fg parallel equals Mg. Well, we said that Fg was Mg, right? So I can just put that in, 215 sine, and what was theta? 35 degrees. So now it's time to go to the calculators. So everyone should have a calculator in hand. Don't call out the answer, type it first, and then we're going to see if y'all get the same answer. So for those who don't know how to do it, we type in on our calculator 215. We hit the trig button, we hit sine, and we type 35. And I'll wait just a second for everyone to make sure that they're with me. Am I waiting on anyone, or are we all good now? Waiting on Whitney. The FG, if you look right here on the board, so look right here, FG equals mg, right? Equals 215. So m times g is 215. Okay. All right, and then we're going to hit enter. Everyone get 123.318933815? Good. That's what we were hoping for, right? Okay, how many sig figs do I have in this problem? Think again. 3, because 215 was 3 sig figs, and 35.0 is 3 sig figs. So that means FG parallel is what? Is equal to 123. What's the unit for force? Newtons. And which direction was this going? Well, not straight down, but down the ramp. Very good. Down the ramp. Okay, so go ahead and box that, because that's an answer. And we always want to be able to find the answers, correct? Yeah. All right, so the next question is, what is FG perpendicular? So unknown. FG perpendicular. Well, what's our equation for FG perpendicular? Good, it's mg cosine theta. Okay, so we just got to plug in again, right? So FG perpendicular is equal to mg, which again is the same thing as the force of gravity, which we have is 215, cosine 35. Okay, so we put it into our calculator. 215 trig cos 35. Everyone got it in their calculators? Still see a couple people pressing buttons, so I'll wait just 1 second. All right, and hit enter. Did y'all get 176.117689522? It's a setting on this calculator. Let me see it real quick. 5. All right. So how many sig figs again? 3. So 1, 2, 3. Is the 1 going to make the 6 round up or stay the same? Stays the same. All phones should be put away. We have 176. 176 newtons. Let's look at our free body diagram. Is it going down the ramp?
Oh, no.
Oh, sorry. FG perpendicular is what I'm looking at. It's going not down. Where is this? It's kind of going sideways and to the right. So how do I say that, though? It's going to be perpendicular into the ramp. Yeah, let me write this and then I'll go back up. Perpendicular into the ramp. Perpendicular is a very good word for this. Okay, so if you see it right here, it's going into the ramp. And remember, it's FG perpendicular, so this is a right angle right here, whether it looks like it when I drew it or not. Remember, it's hard for me to draw lines on this tablet because it's weird that way. Okay? Yes, sir. No, the box could be anywhere on this ramp, as long as the ramp's angle is 35 degrees. Okay? All right. The next question is, what is the net force acting on the box if there is no friction? So the unknown is F net. The equation is F net equals the sum of the forces. So we're not looking for MA right now. We don't have M yet, and we don't have A yet, so we don't know that part. That's the easy way to get F net, but you have to have M and A. So what we're going to do is we're going to look at our free body diagram. So come up to the free body diagram again, and we're going to add the forces on the free body diagram. Okay? So from our notes yesterday, we know that Fn and Fg parallel are the same, correct? Okay, they're the same, but they point in opposite directions, which means when I'm calculating net force, these two things cancel themselves out. So what's the only force that's left? Fg parallel. So that means F net is equal to Fg parallel, which is equal to, what was Fg parallel? 123 newtons down the ramp. Yes, sir. Okay. So we add the forces on the free body. This one is up and this one's down, right? Ish. At least they're up and down-ish. But they're opposite directions and they have the same magnitude. So that would be like 3 going up in the positive direction and 3 going down in the negative direction. So 3 minus 3 is 0. So this part cancels each other out. Okay? So that was 123 newtons down the ramp. All right, so now let's complicate things. And it says, what is the acceleration of the box if the coefficient of friction is 0.240? So I'm going to make a new free body diagram for this one. Our unknown is going to be the acceleration, right? I just need to remind myself of that. So we've got our ramp. Ramp's still chilling here at 35 degrees. Box is still on the ramp. We still have Fg parallel here. We still have Fg perpendicular here. We still have Fn right here. But now there's a force that is going to oppose this thing going down. And we're going to call that the force of friction. Okay? I don't currently know if this thing is moving. I don't know if it's sitting still. I'll figure that out after I do the acceleration. So that's why it doesn't say force of friction static or force of friction kinetic. Okay? And even the coefficient that they gave us didn't say which one it was. So we're going to use the general form. So givens, we still have the mu that they gave us is 0.240? Okay, 0.240. Unknown is the acceleration. Let's backtrack a little bit. We know that Fg, which is equal to mg, is equal to how much? 215? Okay, so 215 is equal to m times 9.8, right? Okay, what's the 9.8 doing to the m? It's multiplying, so the opposite is to divide by 9.8. And so if you do 215 divided by 9.8, what do you get for m? Because we're going to need m in a minute. All right, so on your calculator somewhere you'll have 21.938 and a bunch of numbers. I'll go ahead and do it this so you can see it over here. 215 divided by 9.8 equals that. Okay? Now, we already know a lot of this information, don't we? All right, let's go ahead and fill it in our free body diagram just to make things a little bit easier for us. Let me go ahead and see if I can scoot this a little bit over. Okay, so Fg parallel was how much? 123. Fn is how much? Oh, my bad. It's not 123. That was F net.
Yeah.
My bad. We'll go up here real quick. All right, Fg parallel was 176 newtons. I'm writing on perpendicular and I said parallel. Again, my bad. Fg perpendicular is 176 newtons. And Fn is equal to Fg perpendicular, correct? So this is also 176 newtons. And then Fg parallel, I'm saying it correctly this time, is 123 newtons. Okay. Force of friction is the only thing I don't know here. So before I can solve for acceleration, I'm going to have to solve for force of friction. Okay, so the equation to calculate for force of friction is what? Mu times Fn. Okay. And then the the equation for acceleration is what? A equals F net over M. The reason it's just mu is I don't know if it's kinetic or if it's static at this point. Okay? All right. So let's solve for the force of friction real quick. Force of friction is equal to mu, which was 0.240 times Fn, which was our 176 number. Now, when I do this, I'm going to use it on my calculator. I'm not going to put 176. What am I going to put? I'm going to put whatever was on my calculator, the unrounded answer. Remember, I only like to round at the end. So when I go to my calculator, I'm going to do 0.240 times, and I'm going to scroll up to grab that 176.117 part, and then I'll hit my answer. Okay, so force of friction is now 42.268, right? Okay. So I'm going to write down, just so I remember which numbers are which, I'm going to write 42.268. And now I'm going to go to solve my A equals F net over M. So A equals F net. Where do I get F net from? My free body diagram. So this was F net for a different situation, so don't get confused and use this. F net comes from my free body diagram. So I know that Fn and Fg perpendicular canceled out, right? So I have Fg parallel going left. So that's going to be negative Fg parallel, which was the negative 123. Ff is going right, so that's going to be plus the force of friction, which was the 42.268. And then I'm going to divide that by the mass, which was the 21.938. Now, again, on my paper, I've written all these rounded numbers, but when I go to actually calculate it, what am I going to use? I'm going to use the calculator part. So I got my negative 123, so I'm going to start by opening a parenthesis. I'm going to press negative. I'm going to jump up here and grab that 123. Oh, I'm going to try at least. There we go. And I'm going to do plus, and I'm going to come up here and grab that 42.268 part, right? And then I'm going to go outside the parenthesis. I'm going to hit divide, and I'm going to go up and grab the number that was my mass, that 21.93 part. Okay? So you see how I haven't rounded in the middle. I'm going to round at the end, right? Hit enter. Mm-hmm. All right, so what we should have gotten on our calculator is that the A is equal to 3.69. Did I get a negative? I did get a negative, you're right. Negative 3.69 meters per second squared. Okay, now remember, I need to interpret this negative into a direction, right? So that'll be 3.69 meters per second squared. and the negative direction was down the ramp. All right, so that's like the hardest question. But is it really that hard? It has a lot of steps. Yeah. So we broke it up. We calculated these individual pieces, and then we were able to calculate the force of friction. So this is like the complicated problem on the test. I'll maybe give you one of these. Maybe give you one of these. Now, I might have another problem where I ask you to calculate, like, what is FG perpendicular, what is FG parallel. Okay? So that's the kind of stuff that we're doing. Or I might have another problem where I ask you to calculate what the friction is on just something. Okay? This is a problem that combines it all. So I'll give you some partial problems, but I'm going to give you at least one where you've got to do it all. Okay? All right. So let's look at the easy stuff now since we've gotten through the hard stuff. I'll give you all a minute to copy this down. And we're back.
Yeah.
A 225 kilogram crate is pushed horizontally with a force of 710 newtons. If the coefficient of friction is 0.20, calculate the acceleration of the crate. All right, so we are no longer on an inclined surface. We're back to easy problems. So that means we've got a nice flat surface with a box sitting on it. Okay? So if you got a nice flat surface that a box is sitting on, but you're on the planet Earth, what kind of force are we going to have? Gravity, and it's going to pull you down. Fg, which is equal to mg, which in this case is equal to 225 times 9.8. Okay, so you get out your little calculator. You do 225 times 9.8. And what did y'all get? 2205? That's what I got too. Good. All right, so Fg is equal to 2205. Okay. So what other forces do we have going on? We're going to have friction. What other force? Yeah, the force that we applied, so that's going to be one that's important. Do we want to apply it to the left or to the right? You want to apply the 710 to the left? Okay. So this is 710. Does it matter? Nope, doesn't matter. As long as it's horizontal. Okay? So if I applied that to the left, that means I'm trying to accelerate it to the left, which means that the friction must be going to the right. Okay? It says it's accelerating, so I'm going to imagine this is probably FF. Okay. Okay? What other force is there? Okay, there's got to be a normal force, right? Because this box isn't falling through the ground. That means that there has to be some force pushing it back. And since this surface is horizontal, we'll call this Fn, which it's balanced by Fg, so it's going to be 2,205 newtons. Okay. It says if the coefficient of friction is 0.20, calculate the acceleration. So the unknown is the equation for acceleration is okay. A is F net over m. Let me go ahead and write a couple givens I forgot to write down. I know that we have them, but I just forgot to write them down. So the mu k is going to be 0.20. And the mass is 225. And that equal looked a lot like a 2, so I'm going to rewrite it. Mass equals 225 kgs. Okay. So when I look at here to do FNet, I got to come back up to my free body, right? So the FN and the FG, they cancel each other out. Y'all see that? The 710 and the FFK did not, though, right? But I don't know what FFK is yet. So I probably need to solve for FFK first. So FFK is equal to what? That's right, mu K times Fn. All right, so we'll go to solve. We're going to do this FFK first, and then we'll do the A. So FFK equals mu K, which was 0.20, times Fn, which was 2205. And what do you get? Good, 441. That's FFK. All right, so now we just got to do A equals Fnet. Now remember, Fnet comes from your free body. So I had 710 going to the left, so that's A. That's right, negative 710. I have FFK going to the right, so that's positive 441. Divided by the mass, which was 225. Why did I what? Remember, in this direction, up and down, Fn and Fg canceled themselves out. And the question was in mass. And his calculator. All right, so what do y'all get for A? Negative 1.195. Yep, should be negative 1.2. So I'm going to write 1.2. What's the unit for acceleration? Meters per second squared. And which way? I got a negative. Which way was my left? Or which way was my negative?
Left.
Left. Okay? So whenever I'm looking at your tests, the positive and negative depends on how you draw it, right? So it's going to match up with your drawing. So that's why, I might say left or right was an acceptable answer because it depends on how you drew it. Okay? Easy enough? All right, one more question. This is going to be a review from your last test, so y'all should really have this one by now. No homework tonight. Just study for your test and get your other homeworks turned in. All right. 3 forces are acting on this ring in figure 23. They want to know what is the net force. So how do I figure out net force and add forces when I have multiple directions? That's what we're trying to figure out. Okay, so what we're going to do, I'm going to label these. I'm going to call this one A, I'm going to call this one B, and I'm going to call this one C. Does it matter what I labeled them? No. I could have labeled it Z, Y, and X. I could have labeled them in any different order. The whole thing is I'm just labeling it so that it's clearer to me. Okay, so how do I add up forces that are in opposite directions? I have to get them into their components, their X and Y components, their left, rights, ups, and downs, right? Okay, so just like on the last test, we're going to get a X and we're going to get a Y. We're going to get BX, we're going to get BY. We're going to get CX, then we're going to get CY. And then I'm going to calculate, after I have all of this, I'm going to get Rx, and then I'm going to get Ry, and then I'm going to get R, and then I'm going to get beta. So I need to know not only where it is, but I need to also find out what direction it's pointing. Okay? All right, so it looks like I wrote a lot of work, but it's not going to be very difficult. It's very short work. Okay? Yep. So A is 128, right? So I write 128 and 128. X direction is cosine or sine? Cosine. Remember, y saw the sine. Y saw the sine. Okay? So cosine and then sine. All right, BX is going to be, bless you, BX is going to be 128, and then cosine. And BY is going to be 128, and then sine. CX is going to be 64. And then the X part is going to be cosine. And the Y part is going to be sine. All right, now we're going to fill in our angles. A, how far away from the positive x-axis, measuring like this, is A? All the way to A, from here to here, 180. Okay? For B, how far is it from the positive x-axis to B? 30 degrees. Okay, for C, how far from the positive x-axis is it? 0. Okay? All right. Now I got to do some calculating. All right, 128 cosine 180 is negative 128. 128 sine 180 is 0. 128 cosine 30, I don't know. 128 sine 30 is 64. 64 cosine 0 is 64. 64 sine of 0 is 0. So y'all just got to tell me that one. 110.85. Well, you know, I'm gonna keep it all for that. Okay, so got that taken care of. I'm gonna go ahead and put the 128 cosine 30 on the calculator just so I have it. Trig cos 30. Enter. 110.85, just like you told me. Okay, so to get Rx, how do I get Rx? No, Rx is the easy one. It's AX plus BX plus CX. So that would be AX is negative 128, BX, so plus 110.85. And then plus 64. Okay, so again, I don't want to use a rounded answer, so I'm going to put it in my calculator like this. I do negative 128 plus, go up and click for your answer, and then plus 64. The other benefit is now that's in my calculator. I'm going to need this number in just a minute. Okay. So it's going to be 46.9. But remember, I'm just writing this down to keep a record. This is not going to be used for my answer. Ry, we got 0 plus 64 plus 0 is?
0.
And that was AY plus BY plus CY. Okay? How do I get R? Pythagorean theorem. So R is going to be the square root of R x squared plus R y squared. So that's going to be the square root of that 46 point something answer that you have in your calculator plus the 64 squared. So we go to the calculator again. Square root squared plus 64 squared. 79.3, is that what y'all got? What'd y'all get? Yep. Very good. All right, how many sig figs did we have? Because this is actually an answer, so I got to round it correctly. Yep, we had 2 sig figs with that 64, right? So that's going to make this round to 79. So we got 79, what unit? Newtons, because all of these are in newtons, right? Okay, now how do I get theta? Theta is equal to tan inverse of Ry divided by Rx. So that's going to be tan inverse of 64 over that 46.9-ish answer. So again, I go to my calculator, trig tan inverse, and I do 64 divided by 46.85, all that good stuff. Enter. And I get 53.7, which is going to round to how many degrees?
How many degrees?
Yep, it'll round to 54 degrees.
Oh.
So theta is equal to 54 degrees.
Oh.
So I got 79 newtons. That's one of the answers. I got 54 degrees where? Well, my y and my x were both positive, so I'm in this quadrant, right? And the angle that I measured is from the positive x-axis, so it's 54 degrees. I went up, right?
Oh, oh.
So I'm going to say above the positive x-axis. All right, so that's the full answer. 79 newtons, 54 degrees above the positive x-axis. All right, well, that is a very comprehensive review. Hope y'all had a good time. I know I did. All right, signing off.